In problem number 1, we have to figure out what form this is. So this is an alphabetical form because I have my A, my B, and C, so that's standard form. Next thing I'm going to do is I'm going to figure out my value of A. It goes along with my coefficient of x squared, so that's my quadratic term. A equals 2. That's a positive number, so this curves up. Now I want to figure out, compared to the parent function, is this wide or is it going to be narrow? So I have 2, so that would be narrow because it stretches it out. The next thing I'm going to figure out my axis of symmetry. This is in standard form, so I have to calculate my axis of symmetry. My axis of symmetry is opposite of b over 2a. I labeled my coefficients a, b, c. So the opposite of negative 12 is 12. So I have 12. Divided by 2 times 2 is 4. That's how I got 3. So on my graph, that would be my axis of symmetry divides into 2 equal parts. Because this is standard form, I'm going to take my axis of symmetry, which has to go through my vertex. So I'm going to plug in f of 3, and I put it in my calculator just like this from the original equation, and I end up with 2. So my vertex is 3, 2. It says to find the y-intercept only if you can read it. This is standard form. C is 20. So my y-intercept is 0, 20. In problem number 2, we're going to do the same thing. Notice standard form is ABC. Vertex form, I could read the vertex from that form, and the axis of symmetry. So I am going to label my points ABC. This is standard form, alphabetical order. So my A value, nothing's shown here, so that's 1 because it's identity property. So A equals 1. That's positive, so it's going to curve up. It is going to curve up. If it was negative, it would curve down. So I want to figure out if it's wide or narrow, but it's 1. It's the same width as the parent function. To figure out my axis of symmetry, I have to calculate it. The opposite of b over 2a is my axis of symmetry. b was negative 2, so opposite of negative 2 is 2. So I have 2 divided by 2 times 1 is 2. That's how I ended up with 1. So my axis of symmetry is 1. My vertex, I am going to plug in f of 1 into the original equation, and I end up with 1. So my vertex is 1, 1. Because this is standard form, I can read the y-intercept. So that's how I got 0, 2. In problem number 3, this is not an ABC form because look at my perfect square right here. I'm going to subtract 4. That is vertex form. My value of A is negative 1. That means it is going to curve down. So it is going to look like this. Curve down. I'm going to have a maximum value right here. So I have negative 1. So A is 1. So I am going to have the same width as the parent because I have negative 1. My axis of symmetry, I am going to look right here in the perfect square. What makes that equal to 0? 4 does. So 4 is the axis of symmetry. If this part is 0, I'm left with negative 3. So that means when I plug in 4, I get negative 3. You also can do this by hand. You get exactly the same answer. So my vertex is 4, negative 3. The directions said, tell me the y-intercept if you can read it. Cannot read it in vertex form, I have to calculate it, so I'm just going to write cannot read it. In problem number 4, look, I have a perfect square and I'm adding 4 to it. That's got to be vertex form. I am going to look at A. A equals 2. So that means it's going to curve up. I'm going to get a minimum score. If I have 2, that's going to make it narrow, which is going to be a stretch. My axis of symmetry, I'm going to look right here in the perfect square. What makes that 0? Negative 4. So negative 4 makes the perfect square 0. If negative 4 makes it the perfect square 0, I'm left with this negative 4. That's how I got negative 4, negative 4. If you plug it in and calculate it, you get the same answer. It's easier just to read it. This is vertex form. I cannot read the y-intercept, and that's the answer. In question number 5, we are going to identify the graph. So first I'm going to look over the characteristics. A is negative 1. It means it curves down. You must show that you're not guessing by showing me some characteristic. B is the only one that curves down. B has to be the correct answer. I also could plug in f of 0 and I get 0, 0, so I could see that is correct. In problem number 6, show me some characteristics that you know what you're doing. So I have A is negative 3, so that means it curves down, so I know the first one is incorrect. And the last one's incorrect. So I'm going to find the axis of symmetry, which was 0. And I plug that in, I get 0, 0 for the vertex. So here's the vertex right here, and here's a vertex right here. That did not help me figure out what's the correct answer. So I'm going to plug a simple value in. If I plug in f of 1, so negative 3 times 1 squared is negative 3. So negative 3 is on the graph. So B is the correct answer because I got 1, negative 3, about right there on the graph. And on C is not correct because that is not 1, negative 3, because the point's right there, not on the graph. On number 7, I have standard form. So A is 1, so I know it curves up. So that's not the answer. That's not the answer. My y-intercept is 0, 7 because it's standard form. So I am going to find 0, 7 on this graph. So it looks like it might be up here. I'm not sure, but I could see it can't possibly be on this graph, so I can see that's incorrect. My axis of symmetry, I'm going to plug in opposite of B over 2A, I get 3. 3 is the axis of symmetry. 3 is the axis of symmetry here. I found it. In problem number 8, I notice A is negative 1, curves down. So well, that's not the answer, and that's not the answer. So I have, this is standard form, 0, negative 12 is the y-intercept. So it might be the first one, it might be the last one. So I need more information. So the axis of symmetry, opposite of B, which would be negative 6 over 2 times negative 1 is 3. So in graph A, I have the axis of symmetry is 3, but not in D. So I know A is correct. In problem number 9, we're going to graph this. So my A is negative 2. I know this is going to curve down. This is standard form. So I am going to find my axis of symmetry, I'm going to plug in opposite of b. b isn't listed, so it's 0. So I have 0 over 2 times -2 is still 0. So my axis of symmetry is 0. So here's my axis of symmetry. That's how I calculated it. I am going to plug in f of 0. I get 0, 0, 0. This is written in standard forms. My y-intercept is 0. So that would be showing all the characteristics. In problem number 10, we're going to label our ABCs. This is in standard form. My a is -2. So I know this is going to curve down and it's going to be narrow or a stretch compared to the parent. So I'm going to calculate my axis of symmetry. Opposite of b, which would be 12. So that would be 12 over 2 times -2, so over -4. That's how I get -3. So I put -3 on the graph. My vertex, it's got to go through the axis of symmetry. So I'm going to plug in f of -3. I got -3, -3. This is in standard form, which means I know it's got to go through 0, -15. And if you look at the graph, it looks like it eventually will go through that point.